Okay, today we're going to complete the square, but before we do that, we have a couple skills that we need to work on. Okay, the first I want to remind us about extracting the root, and that's the video before this. If you haven't seen it, you should go watch it. But I'll do an example here from it. So we're going to solve this quadratic, and what we do is, since it's already a perfect squared, we can extract the root. So what I'm going to do is, if it's a perfect squared, I could take the square root of both sides, like so. And when I do that, I get x plus 3 equals plus or minus the square root of 7. Remember, this was the absolute value, and the absolute value has two solutions. Also, you want to remember the power, the degree is 2, and there's two possible solutions, and this is no exception. And now we need to isolate x, so I'm going to subtract 3 from both sides, but I do, now that that 3 is gone, x is isolated, I do like the look of the negative 3 being in the front, plus or minus the square root of 7. And then we have our two solutions. If you want to write them out, it's minus 3 plus the square root of 7, and minus 3 minus the square root of 7. It's usually not mandatory to write both of them out like this. So we can accept both as answers. So that's our goal, and when we're completing the square. This is just extracting the root. It's already a perfect square trinomial, okay? But completing the square, we can solve any quadratic with completing the squared. Our job, though, is to make it look like this. If it's not in parentheses with perfect squared, well, we have to make it a perfect square trinomial. Okay, so how are we going to do that? So before we actually complete the square on an equation, we're going to work on just completing the square on an expression. So we're going to start off with factoring a perfect square trinomial. So this is, and we're just factoring, we're not solving. So it's a trinomial, it gets factored into two binomials. X times x is x squared. 3 times 3 is 9, and plus is, since the middle term is a plus 6, it's plus 3 times plus 3. Let's check. This is 3x, this is 3x, and yes, it does check out. So this can be written as x plus 3 quantity squared, because there's two of them. Okay, so that's a perfect square trinomial. We've got to be able to see that my middle terms, 3x and 3x, is 6x. So this right here, 3, is half of that 6, because you have two middle terms that are identical. So it makes sense that that's half. Let's try another one. What we're going to do is we're going to complete the squared, actually, to make it a perfect. What does this have to be so that we can write that as a perfect square trinomial? Obviously, this is x. I do want to point out that 1 is needed, because x times x squared, x times x is x squared. So if you want to look at it factoring, we do know, again, that has to be half, because it has to be 5. This is going to be x and x. X times x is x squared. And 5x and 5x adds to be 10x. Remember, that number needs to be half of that number, of the middle term. This 5 has to be half of the middle term. And since that's a plus, it does have to be plus, plus, that has to be a plus. So what's my, what number do I have to add here so that it's a perfect square trinomial? Yeah, it's going to be 25. It's going to be my last term. 5 times 5 is 25. So that works. What about if it's odd? What if I have x squared plus 11x? How do I complete that squared? Again, we want this to be a perfect square trinomial. We want, if you want to write it out, both the terms so we can see it, so that it's perfect square trinomial. So we have x and x. My two middle terms need to add to be 11. So that has to be half. Half. So it has to be half because my middle term will be 11 half x. This outer one will be 11 half x. And you add those together, and you have a common denominator, so that's 22 halves x, which does equal to 11x. It works. So you always just take half of your middle term. Okay, that ends up being half. And this is a plus, this has to be a plus, because it has to be plus plus is a plus. And so to fill this in, it's that last term squared, which is 121 over 4. You square that last term. Okay, in general, if you want to do this in general, just so we make sure we have the hang of it, we have x squared plus bx plus, we're doing this in general, what? Again, we take half of this has to be b over 2. And what does this last term have to be? Well, it has to be that last term squared, which is b over 2 quantity squared. We want to solve by completing the squared. So what we're going to have to do is we want to do exactly what we have been doing. We want to add an amount to make it a perfect square trinomial. We don't really want to have to mess with that 7. So I'm going to add the opposite of that to both sides. Okay, so I bring the 7 to that side, and then this way, I'm going to add something here to complete the square, but if I add it on the left side, I have to add it to the right side. And I want these 3 terms, I want to add something so that it's a perfect square trinomial. Well, what's the formula here? My 2 middle terms need to add to be 8, so it has to be half. Half 4x plus 4x is my 2 middle terms will be 8x. So what am I adding to make this a perfect square trinomial? Yeah, that last term squared, which is 16. So I add 16 to both sides. Okay, so what we have here is this trinomial, after I added 16, is a perfect square trinomial. You can FOIL that out and you can see it. X times x is x squared. 4 and 4 is 16, and your 2 middle terms. Okay, so over here, it's minus 7 plus 16, which is 9. So now, doesn't this look just like the very first problem? It sure does. So now we just extract the root. So now I take the square root of both sides, and I get x plus 4 is equal to plus or minus the square root of 9 is 3. And x, I subtract 4 from both sides, is equal, that isolates my x, minus 4 plus or minus 3. And that could be added and subtracted, so it's minus 4 plus 3 and minus 4 minus 3 are my 2 solutions, but you got to take it one step. Minus 4 plus 3 is minus 1. Minus 4 minus 3 is minus 7. So 2 solutions. So this particular one, notice how we got integers. So if we got integers, this particular quadratic could have been factored. So let's go back and write the original. It was x squared plus 8x plus 7 is equal to 0. So let's solve by factoring. So we factor x times x is x squared, 7 and 1, plus equals 0. 7x, 1x does equal to 8x, so we have everything equal. We set each factor equal to 0, and we get the 2 same solutions. Of course, if you can solve by factoring, that's going to be easier than completing the squared, but I wanted to show you that it does work. This process does work. Okay, let's do another one. Okay, we're going to solve 2x squared minus 4x plus 8 equals 0. Now, remember what I said. It was very important when you complete the squared that you don't have any coefficient in front of the x squared, so we have to get rid of it. We do need to either factor out the 2 and then divide by it. So I just say we could just divide both sides by 2. Divide everything by 2, and then that monomial division gets distributed. We get 2x squared divided by 2 minus 4x over 2 plus 8 over 2 equals, that gets absorbed into the 0, which is x squared minus 2x plus 4 equals 0. Okay, so we are ready to complete our squared, almost ready. So what we want to do is get rid of that constant over there so we don't have to figure out how much to add to make it a perfect square trinomial. So we just move the 4 to the other side, and then I need to add something to both sides, right? Figure out what to add to both sides to make this a perfect square trinomial, okay? That needs to be a perfect square trinomial. And so it has to be an x here, because x times x is x squared. And this term has to be, I'm going to have 2 middle terms here that are going to add to be minus 2x. You're right, it's going to be half of 2 is 1, but since that's minus, it needs to be a minus. So then we can see minus x will be my 2 middle terms, will be minus 2x. That's going to work out. And so what I'm adding to this left side to make these equal is the square of negative 1. The square of negative 1 is minus 1 times minus 1 is plus 1. So I add 1 to both sides. Okay, so I add these two terms. Minus 4 plus 1 is minus 3. I'm ready to extract the root now. I take the square root, I take the square root, and then I can extract plus or minus that I, that negative comes out as an I square root of 3. And I add 1 to both sides, make it look pretty, and put it on in the front. And I have my 2 solutions. Okay, we're going to solve one more. So here we have a quadratic that's not in standard form. So let's go ahead and get that in standard form, putting the largest degree first. So I'm just rearranging my terms. Okay, and now we probably want to get rid of that constant, throw it to the other side by subtracting negative 1. And we remember the leading coefficient has to be a positive 1. So we do need to divide both sides by negative 1. And that will get distributed. Basically, it'll change both the signs, all the signs. And now we're ready to complete this squared. I'm going to be figuring out what to add to both sides to make this left side a perfect square trinomial. Okay, so there's no number, so that's a 1. I need to do half of that 1, which is 1/2. And since it's a minus, we need a minus. And you can see my middle term will be minus a half x. Minus a half x is minus 1x. That's going to work. So what am I adding to both sides? I'm adding that last term squared is 1/2 squared, which is 1/4, 1/4. So now I can add these two. Now in order to take the square root of both sides, we can't take the square root of 2 terms. So we do need to find a common denominator and add that. So let's go ahead and make this a 4 over 4. That's times 4 over 4. So 4 plus 1 is 5/4. So now I'm ready to, now that I have one term on the left, I'm ready to take the square root of both sides. I get x minus 1/2 is equal to plus or minus, I could take the square root of 5 on top over the square root of 4, which is 2. Almost done. Now we need to add the half to both sides. I'm going to add that half to the front. And that looks like we can stop there. That looks like a good answer. If you want, you can see we have a common denominator. It's 1 plus or minus the square root of 5 over 2. We can definitely write it both ways. It's or. So that's our completing the square. Be sure to watch the next video, which is on quadratic formula.